Welcome to Ham Radio Networking, and today we're going to be talking about 3D printing stuff. So, I just got a new shipment of our 3D filament from Amazon for $10 for 4 spools of 250 gram spools, and 4 of those. So, it's pretty cheap filament. It's also silk filament. So, let's see how well it prints on a 3D printer. And here is some little things that I've 3D printed so far. This little name holder. Says has the call sign, and also my name as well. I've done another one for somebody else. I've 3D printed some little Nerf dart guns, as well as some butterfly knives and a bunch of other things. So let's see what other cool ham radio things that you can 3D print, and I'll tell you the story of how I got this 3D printer. Alrighty, so this is the 3D printer. So this is the filament in here. All you do is you place it in here. Since this is a smaller spool, this printer was designed to have the smaller spools. I did buy a bigger spool, but I decided just to get 4 smaller spools for the price of less than just 1 big spool. And it also contains the same type of material. I'll leave a link into the description of this. It prints very well compared to Overture. The Overture stuff did not print very well at all. So I'm going to go ahead and install this filament, and we'll start printing stuff. We have the filament loaded in. Now let's go onto the computer and show you how all the magic is done. Okay, so we're on the computer. So a lot of people, we use this website called thingiverse.com. And so Thingiverse is an amazing website that has tons of 3D prints that people have made. So we look on this side. There's this one person who, on his computer, or possibly even his tablet, he 3D designed this, and then he wanted to go show the public, hey, this is a Morse code key, and if you want to use my design and print it, you can. So you download one of these designs. I'll download this, open this folder, and if you extract it and open up a slicing software like this one right here, the slicing software converts your image that you use, and it turns it into something that the printer can read and understand. So basically it takes the image and converts it into a G-code file, which is what the printer uses to print it. So this is what the printer looks like when doing it. I'm gonna move some of these pieces just like that. Perfect. Okay, and so when you click start slicing, you can turn the bed temperature up, the extruding temperature. I find that 63 works the best for my old filament, and it's working fine with the filament I'm using now. You can select some of your print speeds. I like to use 80 on prints that I don't care if there's a little mishap. Otherwise, I just use 50. Then there's the shells that you can input. Basically, you can adjust all the settings on what your printer does right in here. And then once you slice it, which is what I'm going to do now, basically you just slice it, look at the preview. If everything looks good, see, it'll take 4 hours to print it, and I'll tell you how much material it's going to use. So in this case, it's going to use 51 grams of material, which 51 grams of material with the filament that I just bought equivalents to around 50 cents. And so this will show you how it goes. So when it prints, it'll print the outside, and it'll print something on the inside called infill to give it some support, and I'll start making everything here just like this. And then you just click this little printing icon. Now you can download the file, plug in a micro SD card, plug it into the printer, and print it that way, or you can use your Wi-Fi or Ethernet cable. Just click that, and then it'll automatically print for you. That's all you have to do. You wait till it's done printing, and you're good to go. So that's how easy it is. Now let me show you what I'm going to go print here. Alrighty, so I'm printing right now, and you can print various other things. I'm going to go print this, and so I just click start slicing. I make the adjustments to what I want to do real quick, and then I hit slice. And so it's slicing right now. And then once it's done slicing, I'll preview it, make sure everything looks good. If everything looks good, then I'll go ahead and print it off. So this will take me around 4 hours to print, almost 5 hours to print all of this. It'll probably end up taking 5 hours to print all of this. Now click this button, click print, click OK, and now it's going to start printing right now. I hear the 3D printer starting to make noise in the background, heating up the extruder and getting ready. So let's go look at some things that you can print for ham radio. You can 3D print like this, a CB+ ham radio mic holder, so you can mount it to your truck. Same with what this is right here. One really cool thing is, what I like is a little ground plane right here. I'll open this. This is something that you can put a little spring on. This is what it looks like after it's done printing. It'll look like that, and then you can run your coil around it, and it would be a ham radio ground plane, and this is designed for 20, 30, and 40 meters. A ham radio stand, so you can stand your radios up without them falling over with the slightest gust of wind, or in my case, with the slightest knock on the table. More ham radio mics. There's a mounting bracket, so you can make your own customizable mounting bracket. And this is another really cool thing. Unlike all the designs on antennas, so this is a design that you can make to hold up a dipole. And this doesn't necessarily have to be metal. It can be just this, where you put in your SO239 connector, and then using these little holes here, you can mount wire onto it and then have a wire making a little dipole. Ham Radio Dude has made a lot of cool things, including wire winders. So if we go to his page, this is something really cool. Here, this is a portable in-fed half wave that you can 3D print and then make it yourself. This one's for the BNC connector. He's also made one for the SO239 connector right here. So if you have some wire and some stuff laying around, and he also has a video on how to make an in-fed half wave using a 3D printed port like this. And it works very well. And one really cool thing is, what I would love to do is make a ham radio sign that has your call sign and name. And I'll also show you one of my designs really quick that I did. Took this guy's design and remixed it. So this is what I designed. It's a little case that you can have with your name and your call sign. I really like this one. This is the one I made. Currently has 7 downloads on it, and I remixed it from this guy. The reason why I remixed it is because I wanted the call sign to be a little bit thicker, as well as a customizable name. So when I printed it, I made it to where you could put your own name and call sign on it. And also, you can go into something like Tinkercad, create something like this, and you can design something yourself, or you can take someone else's design and design something. So I could do something like this, put it down, stretch it out a little bit, go work on a different area. And if I wanted to make my own customizable in-fed half wave, I could do that like this, and then I could use circular objects that have a hole in it. That it can be a little tricky, but with a little bit of practice, and I'm not really good at this at all, you can design your own little in-fed half wave. And there's also better software like Prusa 360 that require a way deeper learning curve, but something like this, you could design your own little sign, and it would be a great project. But most people, they just use someone else's designs on something like Thingiverse. I'm gonna do something called ham radio and networking, and so you can make a little sound like that. And so let's talk about the Anycubic Pro Neo. This is a excellent 3D printer. This is like a slightly newer and better version of the Ender 3. So the Ender 3 is around $200, and it's one of the budget printers. This one is very similar to it, but it has a few more tricks up its sleeves, and it's also a little cheaper. This printer prints a bit faster on the default than what the Ender 3 does. It has an automatic leveling system, which is always nice, so you don't have to manually level everything yourself. And it's a lot easier to put it together compared to stuff like the Ender 3, which can take anywhere from a few days to a few months. I've known some people that took 3 months just to do that, to put together the Ender 3. This, if you were to do an Ender 3 in 3 months, this would take like a month. But most people can set up one of these printers in around a week. You just gotta adjust your settings and get the slicing software easier to work with, and that prints everything better. But this has a bigger print area than my printer. My printer is very small. It's only a 150 by 150 by 150 millimeter square, or cube I should say. So I'll leave a link in the description of this printer here if you want to purchase it yourself. If you want me to have like a little 3D printing tutorial, leave a comment and I will make another video about this. And I will also be making a couple videos if I design something that I believe is really cool, or if I believe could be interesting. And it also, if you want to support me on printables. So with that, I'll say 73. Thanks for watching this video. If you have any questions, leave in the description, and watch this, my newest video, for more content on this ham radio channel.